Welcome back to Lehto Files, where we investigate UFOs and delve into the mysteries of the universe. I'm Chris Lehto, retired F-16 pilot, and today we are going to take a little detour from the usual UFO content. Once a month, I like to explore fascinating theories about our universe, and today's topic is truly mind-bending. We'll discuss a scalar model of the universe, general resonance theory, and cutting-edge MRI studies. Buckle up and let's dive in. Chris Lehto, welcome to Lehto Files. Ever since I can remember, I've been pondering a captivating theory that humans are like cells within larger cybernetic organisms, such as corporations and nations. This scalar model suggests that this organization extends far beyond what we can see or comprehend, from the microscopic to the cosmic scale. Imagine galaxies being arranged in patterns similar to the neurons in our brains. To understand this idea, let's first revisit general resonance theory, or GRT. GRT is a theoretical framework that posits cognitive processes based on the dynamic interaction of brain networks interconnected through resonance. The brain processes information by engaging different networks through the synchronized oscillation of neural activity. What is that synchronized oscillation? So we're talking resonance, synchronization within neuronal activity. It's electrical signals, right? So we're talking about frequencies. We're talking about frequencies of vibration. Here's another way to think about it. The resonance theory of consciousness is a neuroscientific theory that suggests that consciousness arises from the resonant interactions between different brain regions. The theory proposes that the brain's various regions interact with each other by means of synchronized neural oscillations. According to this theory, consciousness emerges when these neural oscillations become synchronized across different brain regions, creating a unified and integrated neural representation of the world. This theory is still being studied and has not yet been fully accepted by the scientific community. If you've heard of Penrose's model of microtubules, allowing consciousness to appear inside of our brains, that's through these microtubules. How does that relate? Well, thanks to AI, we've had recent groundbreaking neuroimaging research, November 2022, out of Japan. So look at this. This is just insane. So in this study, these are the images they had humans actually look at, and then these are the images that popped out. So here's the paper, High Resolution Image Reconstruction with Latent Diffusion Models from Human Brain Activity. Don't worry, we'll explain all that. The researchers propose a new method based on a diffusion model to reconstruct images from human brain activity, obtained via functional magnetic resonance imaging, fMRI. They rely on a latent diffusion model called stable diffusion, which reduces the computational cost of DMs, diffusion models, while preserving their high generative performance. This model allows for the reconstruction of high-resolution images with high fidelity, straightforwardly, without additional training and fine-tuning of complex deep learning models. Think about that. You don't need ChatGPT-4 to run this. All you need is simple, stable diffusion. Let's read the abstract quickly. Reconstructing visual experiences from human brain activity offers a unique way to understand how the brain represents the world and to interpret the connection between computer vision models and our visual system. While deep generative models have recently been employed for this task, reconstructing realistic images with high semantic fidelity is still a challenging problem. So it's still difficult, requires a lot of computational effort, except they found, here we propose a new method based on a diffusion model to reconstruct images from human brain activity obtained via functional magnetic resonance imaging. So MRI data, right? It's reading your brain electric signals. It's really what it's reading, okay? It's reading maybe that resonance, those connections, those neural network frequency connections. More specifically, we rely on a latent diffusion model turned stable diffusion. So stable diffusion is these texts, right? Images from monkey riding a horse, stable diffusion, okay? It uses simple coding, simple neural network coding, and allows a monkey on a horse to appear, okay? It's kind of weird. Look at this. There's like weird monkey head coming out of this horse. So it's strange, right? But they use that same technique to read people's brains and output an image. That's just insane to me. So back to the paper. This model reduces the computational cost of diffusion models while preserving their high generative performance. So that means making it cheaper. This is the thing. AI is going to get cheaper and continually will get better. It's not going to get worse. We also characterize their inner mechanisms of the LDM by studying how its different components relate to distinct brain functions. We show that our proposed method can reconstruct high resolution images with high fidelity in straightforward fashion without the need for any additional training and fine tuning of complex deep learning models. This was an amazing learning point for me as well, is that these AI models, right? You can just train a dumber, if you will, AI language model against a really smart language model, such as ChatGPT-4. You can train a fast, cheaper, cost-effective model using these advanced AI models, and you get relatively the same performance. We also provide a quantitative interpretation of different LDM components from a neuroscientific perspective. Overall, our study proposes a promising method for reconstructing images from human brain activity and provides a new framework for understanding diffusion models. Please check out our webpage here. So these are the images here, right? Here's the actual object and then what came out. I mean, that's pretty close, right? Here, I don't know, this is humans. They don't want to use real people. Kind of a dark forest. Here's a plane. Here's, I don't know, people snowboarding looks like. Maybe they just covered up their faces. Here's somebody snowboarding. There's a clock tower. And look at that, a train, old steam engine. I mean, it's hard to tell there, but pretty amazing. Here's someone across different subjects. Okay, so you have different people. Here's what the image they used. And now subject 1, subject 2, subject 5, subject 7. Okay, so man, they're able to read people's brains, the images coming out of that. So think about what that implies. And it's just going to get better. Now you can do that for animals. What about animals? Curious what your cat's thinking, what your dog's thinking? I mean, I could see this being some cheap brain reading technology. I'm sure I'm going to get a lot of issues in the comments. This research offers a unique way to understand how the brain represents the world and interprets the connection between computer vision models and our visual system. This could also relate to other animals. Imagine what your dog is thinking, what your cat could imagine. You probably already kind of know, you can tell, but now we can read it. We can tell for sure, man. Think that would be insane. This cutting edge research on reconstructing visual experiences from brain activity also supports the scalar model of the universe and the general resonance theory we discussed earlier. As we continue to unlock the mysteries of the brain and develop more advanced technologies, we might better understand the nature of resonance within and between different levels of organization, from the microcosm of our brains all the way to the macrocosm of the universe. As below, so above, or as above, so below. As a YouTuber on LehtoFiles, I see myself as a part of this more extensive neural network. By connecting with you through shared experiences, ideas, and information, my role within this vast network is analogous to a neuron transmitting data within the brain. If we embrace the scalar model of the universe, it could revolutionize the way we perceive our existence and our interconnectedness. By recognizing that we're part of a greater whole, we might be inspired to work together in harmony to understand better and navigate the complexities of the cosmos rather than just fighting each other. This perspective might even shed new light on our investigations into UFOs and other unexplained phenomena, and there's a lot of it out there. So there you have it, a mind-expanding theory that connects the microcosm of our brains to the macrocosm of the universe. The microcosm is fMRI reading, and the macrocosm is the actual universe. I've shared this before, but this paper, quantitative comparison between the neuronal network and the cosmic web, this paper shows that there is a tantalizing degree of similarity that it seems to suggest the self-organization of both complex systems is likely being shaped by similar principles of network dynamics, despite the radically different scales and processes at play. I'd love to hear your thoughts on the scalar model of the universe and its implications. This is how the neuronal process works. Connecting with you guys. You can join us on our Discord, link in the description. And thank you for joining me on this journey today. If you enjoyed this video and would like to see more videos about UFOs, mysterious phenomena, and mind-bending theories, Make sure to hit that subscribe button and turn on notifications. Until next time, take care and good luck to us all. Peace.